lot of interesting products. We hit the Hongshi booth, and I'm here with.
I am Liu Yi from Hongshi. We are focused on MicroLED, microdisplay chip, and currently we have the mono green MicroLED panel in mass production, and we just released our RGB color light rendering. You can
let's go there.
Okay. Here. Here.
So what do we have here? What's the resolution of this?
640 by 480.
Oh.
And the brightness is 2.5 million nits.
Wow.
And the volume is 0.35 cc.
Yeah. So this is like 3 individual panels?
3 individual panels combined together through optical components.
Yeah. So what's the energy consumption of this projector?
Less than 200 milliwatts. And our mono red, the red color, we achieved 2 million nits. It's a record.
So you already have customers probably coming to you and wanting to put this into glasses.
Yes.
So how do you see the market evolving in the next 2 years?
Next year, firstly should be the color, the AR glass with RGB color light rendering in mass production, and but the mono green still the market increased rapidly.
Yeah.
Like for the specific function, like a translation or some, when someone do the speech, I can wear AR glass. I can use this as a tool.
Yeah, that's right. So you don't want to overpower things, right? So if you have a specific application, you need then to look at what type of display you need, right? And not like have like the high resolution RGB display and then you have a battery life of half an hour.
Yes, and we hope our more customer can test our sample, our engineering samples. And I will attend the MicroLED event in Holland by the end of this month.
So what will your talk be about?
About our Hongshi MicroLED color strategy.
Very interesting. So is this the single panel strategy, or is it like how you combine them?
Currently the focus of Hongshi is on RGB color light rendering, but we still improve our monolithic color.
Yeah.
Our resolution is 640 by 480.
So that's the most popular.
Yes, and we can see another product from other company. They are 300 by 500. But we think the VGA is a basic resolution. We think the next product should be the smaller, such as 0.1 inch or 0.08 inch, and the resolution may be a little higher, like 840 by 800 by 600.
So you would say for the applications that you're targeting, right? So the apps on the glasses, you need this resolution. You can't go below that. Yeah. So, and where are you trying to go in the next few years? Is it like 720, or what's the goal for this decade?
Our next generation is the smaller pixel pitch, 2.5 micron, and the size can be 0.08 inch, and keep the same resolution, VGA resolution.
So how do you see the prices evolving? Are the prices for the display now stable, and would you say we're already at a point where they're good enough so that they can be put into consumer smart glasses, or does the price have to go down a little bit further?
The price should be go down.
Yeah.
In next year, whatever monochrome or RGB color, or maybe in the future the monolithic color. If the chip the price too high, we cannot achieve the market. The customer, the end customer won't accept.
Yeah. So when do you think we will see the monolithic RGB?
2027 or 2028.
Oh. And would you say the applications are more for consumer or more for business, or for both?
Both. For the color, maybe more consumable, and for the mono green or mono color should be the 2B, some specific application.
Let's take a look maybe at the helmet. Oh wow!
Here's a projector, monochrome projector inside, and here's some special optical design on the visor. It's for the riders.
Yeah.
Yeah.
Can you turn it a little bit up so that we can see the projector? Oh, there it is, right? Interesting. So it's similar to what was used with LCD displays, large LCD displays, right?
And
with the Buckeye optics.
We have another. We have a camera here.
So what's the camera used for in this? So what's the application for the helmet?
For some scenario is if you are a logistic guy, you can scan the goods or barcode or like QR code, and you can receive the information. You can see.
Because that's a very busy job, right? And you have to be very fast.
Yes. Can be connected with the smartphone or your IoT device.
For navigation, also information about the next customer, right? What am I delivering to whom?
Yes.
And this market will only grow because people are very lazy, right? They want everything brought to them.
Yes. The riders, the hands free. You can take the goods or package.
Exactly.
And you can get some key information.
Yeah. So it will make everyone more efficient,
improve the efficiency, and make them work safer. We have some customers very interested in this product.
Yeah.
We have different business lines. Of course, the MicroLED is our core business line currently and in the future. We have our own facility. This facility started to do the semiconductor packaging and like that things from the 2017. So we have sufficient engineering background. For the monolithic color, the customer's spec requirement, also our design standard is 2 million nits. And for the RGB light engine, I think it's also need 2 million.
So you still have a little bit of work to do, but maybe next year you can achieve it.
Yes. Let me explain here. For the monolithic color, the 1.2 million nits is the first version sample we lit up 1.2 million nits, and it's an outstanding brightness record already. And for the mono red, it's the quantum dot. We achieved 1.5 million nits. For the green and the blue, it's the MicroLED. It's from the material. But for the red, we use the quantum dot QDPR color conversion based on the blue transfer to red. And Hongshi is the only 2 companies in the worldwide to achieve the mass production and the shipment of monogreen microLED display product. And as we see in next year, there won't be 3rd company can deliver shipment the monogreen.
There's still problems for other companies to really...
because we think there's, you know, if you make a sample in your research lab, it may be not too difficult. You could, but if you achieve mass production, you have to solve many engineering problems. You need to achieve a reasonable yield. Here's the figure to show what a hybrid stack structure is. You can see from the top view, in the bottom layer is the green pixel, and the second layer is the blue, and on the top we use the quantum dot to transfer blue to red. So the full pixels is a color pixel, and with the every single pixel is subpixel. So for this the pixel, the color pixel pitch is 7.5 micron, and the subpixel is 3.75 micron. We the IP we purchased the IP, and we purchased the CMOS backplane. But this backplane not the public for every company. We customized this CMOS backplane. I want to introduce this for the monogreen. We use the metal bonding process for 8-inch silicon-based gallium nitride wafer. The gallium nitride IP is CMOS driver backplane. After the metal bonding, we do the wafer-to-wafer bonding, and then to the substrate removed from here to there. It is a standard semiconductor process. After the wafer cut wafer into dies, we do the package, put the dies on the FPC, packaging and test. We can ship out the panels or light engine to our customers. And Hongshi is the first company to use the 8-inch silicon-based IP wafer, because it is a very important point, because you know the Shanghai's company, they use the 4-inch sapphire, and we don't follow this technical line. Not only the cost fact, but also the development schedule. You know, the wafer, the 8-inch silicon-based wafers semiconductor industry or supply chain in China is the whole supply chain can support you achieve your project or your deliver sooner. That's why we got the
high-speed development the past few years. Here's our facility. We have enough production capability, and our facility has a well-established quality management system. Because of our other business line, such as the camera module, we have the end customer SQE perform the audit, annual audit every year. ASUS, Quanta, or other end customer quality SQE engineer goes to our factory to do the audit.
Hi, hello. My name is Eddie. I'm from Raysolve Optoelectronics. It's a company in Suzhou, China. And actually, we are working on the MicroLED and its full color microdisplay for AR glasses. And here is our full color MicroLED display demo. It's very bright. Yeah, PowerMax 1 is our series name. Yeah, there's the full color actually. And there we can see the full color projection demo. Yeah, this full color projection uses a very small, tiny light engine. The light engine size is 0.18 cc. It's the smallest full color light engine in the world.
Wow.
And current resolution is 320 times 240 QVGA. Right now we are shipping some samples to our potential customers.
Yeah.
In China and also in other countries.
Yeah. Because it's still very new, right?
Yeah, it's a new technology, and we do all the color pixels on the same chip. It's a single chip solution.
In the subreddit where I share the news, right, people always asking, why is it still only green? We want full color. When do you think we can see full color smart glasses?
Yeah, I think in next year, 2026, we may see some more mature full color micro-LED solution for the AR glasses. And I think we may be the first one can launch some more meaningful full color display for the market. I hope so.
Yeah. Yeah, we're looking forward to it. But still, monochrome will always play a big role, right, for the foreseeable future.
Yeah. In the next few years, monochrome may have their market needs because it's maybe cheaper, and also it can provide high brightness in current situation.
Yeah.
Yeah.
Until the optics get more improved, right? Because they need to be more efficient too.
Yeah. Actually, we see waveguide efficiency is keep improving.
Yeah.
And so we think that in maybe 1 to 2 years we will have some good optical solutions for AR glasses.
And how bright are these displays?
The price?
How bright at the panel level?
In our current situations, the maximum brightness from the display is 500K nits. That's the current maximum display brightness.
Yeah, and that's for green or for what?
For the full color.
Oh, wow.
Full color. So we target about 1,000K nits at the end of this year. We keep improving the light extraction of the whole devices.
Yeah. And what kind of optics can you use with this brightness that you're targeting? So because now we see even OLED coupled with like diffractive waveguide. So like 50,000 nits gets them like 300 nits.
It's not bright enough.
It's not bright enough, right?
MicroLED is necessary for AR glasses.
Yeah.
if
For
the AR
outside especially.
Yeah. For AR glasses, they must need the diffractive waveguide.
Yeah.
And the diffractive waveguide efficiency is low, so micro-LED is the only way to work with waveguide techniques.
Yeah. So your customers are not that interested in, let's say, like reflective waveguide.
I think there's some problem of the refractive waveguide. The mass production they still have some problem, and also the yield problem of the application.
Yeah.
And actually, we have the AR glasses demos, and we use
let's go there.
Our micro display and also the diffractive waveguide. Yeah, that's the AR glasses demo.
Very popular.
Yeah, this is the first AR glasses prototype use our single chip solutions, full color micro LED, and it works with SRG diffractive waveguide. Yeah.
So this is similar to what's in HoloLens, let's say.
Yeah,
I think
HoloLens use the diffractive waveguide.
Yeah.
But the light engine is not micro LED.
The light engine is different. Yeah.
It's different. I think HoloLens is using LBS.
LBS. Yeah. Not that popular anymore.
Yeah. We currently use 8-inch wafer process to do the micro LED fabrications. That's the 8-inch wafer.
Yeah.
That's how we make the micro LED.
So everyone started maybe with 4-inch.
Yeah.
And now we're going to 8-inch, right?
8-inch. And it's more competitive using the 8-inch wafer process. We can make more chips, micro display chips on the same wafer.
Yeah.
Just example, for one 3-inch micro display in one 8-inch wafer, we can make over 1,500 chips in one single wafer.
Yeah.
It's more productive.
Yeah. And is any micro LED company using more than 8-inch? 8-inch is the standard now, right?
8-inch is the largest.
Yeah.
Maybe later on, then it will go to 12-inch wafer.
And that's where the OLED is at the moment, right?
Yeah.
But for micro LED, 8-inch is the standard now.
We are building up our capacity currently, and our headquarters in Suzhou, China, is R&D facility.
Yeah.
And we are working on the mass production in different cities in China. And so in current situation, we just start the productions phase, and I hopefully in the early next years we will have the production ready for the market for our customer.
Yeah. So maybe like 2027, maybe then the capacity will be high enough for really mass market.
Yeah. I think 2027 is very critical years for the AR markets, including waveguide, including micro LED.
Yeah.
At that time, the technology will be much more mature for the customers.
Yeah. So full color at the moment, people are still looking at alternatives, right? Like LCOS. So maybe in 2027, micro LED will be ready to.
I think micro LED will be the dominant technology in the market.
Yeah.
Yeah, because the LCOS have their own problems, the light leakage, and also the power efficiency problem.
How much energy do your displays take? How much do you need to power them?
In our current chips, and when we set the APL, every pixel level at 10%, and the power consumption is around 200 milliwatt. Yeah,
and that's for monochrome.
That's for full color.
Full color.
Full color.
So you're always pitching the full color because that's your advantage, right?
Yeah, that's our advantage. We use our own quantum dot solution for this micro display.
Yeah. And do you have like a roadmap where you want to go? Do you want to make it more efficient in the future, or is like 200 realistic for 2027?
I think the first priority is that we keep improving the brightness. If we have enough brightness, we can lower down the power consumption of the chip. And I think it's the most critical.
It's a priority.
The first priority for the for current markets. And the second one is improving the resolution of the display. And you know, the micro-LED has problem of the size effects. If we decrease the decrease the pixel pitch size, and the micro-LED emission efficiency will be decreased. And so, if we have a larger room of brightness, so we can improve the resolution, and this is the second priority. And the third priority is the color performance. That's we think this the market requirements.
So the 320 by 240, that's maybe not the end goal, right? So what is the resolution that you're targeting? Is it like the 640 by...
Yeah, I think the next step may be VGA 640 by 480 is the next step. And we also need to decrease the pixel pitch in order to keep the same display area. So with color conversion, how do you decrease it? So I know like some companies are working on like stacked pixels, right? But you don't do that with color conversion. Yeah, I think the stacking process is even more challenging and for the mass productions, and because you need to put two different epitaxy layers on top of the CMOS wafers, and it involves a lot of the fabrication process that will kill the yield of the productions. And so we believe that the quantum dots process is more mature because we use standard semiconductor process to fabricate it, and we use standard photolithography. It's more mass producible. That's what our advantages, and I think it's more achievable and faster for the market. We also have a green and red micro display for AR glasses, and you know, green micro display is very common in the market, and we also develop our own red micro display.
So it may be flickering a little bit in the video, but you can see it with your eye. It's just the...
And for this red color micro-LED is done by color conversion. And the basic is the blue micro-LED, and we put quantum dots layers on top of the blue micro-LED.
So because the red is very hard to achieve with other materials, right?
Because for aluminum indium phosphide, it has some reliability problem because the efficiency drops very significantly if the chip the temperature is high. So for QD, it has advantages about the stability at high temperature. And also it can have a very stable wavelength. It's that's advantage.
With QD, I'm not sure if I remember correctly, but there were some problems with the lifetime. Is that still a thing, or is QD like, is it okay now?
It's conventional. And traditionally, QD has a problem of the reliability, and so normally it's only used in TV backlight as a QD film for full backlights. But because we know this problem and we want to fix this problem, so we have our own material team to do the synthesis and also the quantum dot photoresist for our process. So we know the material itself, and we do the synthesis and try to fix the problem. Also, we mix the quantum dots with the photoresist, and photoresist itself can protect quantum dot also, so it can apply on top of our micro-LED.
How does it work?
We do photoresist quantum dot photoresist, so we can do the patterning of the photoresist by photolithography process. It's a standard semiconductor process. So we do everything on through the fabrication process, from the blue micro-LED and convert it to the full color micro display. It just involves two photolithography steps, red and green, spin coating, photolithography, and also develop to form the patterns on top of MicroLED. That's how we achieve full color pixels. Yeah. In one color pixel, it involve one red, one green, one blue, and two green, because the green composition is large in white color, so it requires two green subpixel. Yeah.
And how efficient is this color conversion? So, how much light do you lose?
Actually, for the quantum dot film layer, the layers and the quantum dot quantum yield, conversion efficiency is around 60% for the film. But after put it on the MicroLED, because we need to make some crosstalk avoid the wall to avoid the crosstalk between subpixel, and it will also decrease the efficiency of the light conversions. Yeah. So we keep improving the light conversion efficiency and also the light extraction efficiency of the device, so we can improve the light output power of the.
Well, thanks so much for the explanations. Thanks for the interview. Thanks for talking to us.
Norman.
Hey,
Norman.
Hey, we're here at the booth of Innovision and we're talking to Newton today. Newton, please explain what your role is at Innovision and what Innovision does.
It's my pleasure to have an opportunity to introduce our company. Well, your media platform is my honor. Okay.
Thank you so much. Thank you so much.
Okay. So I will have a brief for our company. Innovision is a startup company. We founded in 2021. We focus on microLED, microdisplay. Our headquarters located in Suzhou City. Our factory located in Huzhou City. This is a 4-inch line. 4-inch wafer line is our in-house fab. The fab's capacity is planned 40,000 pieces wafer a year.
40,000 wafers?
40,000 pieces wafer, 4-inch wafer.
So how many displays fit on 40,000?
Okay, if you transfer to display panel, such like 0.13 ones, that should be more than 10 million pieces.
Well, that's
this is our capacity. Capacity.
That's your own factory.
Yes, our factory, our own factory. Our core technology is vertical stacking process for mono full color display panel.
So a single panel and all the 3 RGB colors, right?
Yes,
on this.
Yes.
So and you stack. Why do you stack the LEDs?
You mean how to stacking?
Why do you stack them?
Actually, I think if stacking will be more compact, more smaller, and lower power consumption, and more friendly for your application for AR glasses. Okay. So this is our core technology.
But that's what you will make.
Yes, you're right.
So you will change that. And what about the monochrome? Because nowadays all the displays that are on the market, they are still all monochrome, right?
For now, yes. Single color, monocolor is a major application in the market, because don't have a mature full color display. Maybe next year or even longer will be full color or polychrome AR glasses in the market.
And for the smart glasses, what kind of size and resolution are most customers asking for?
Actually, customer no choice for now.
Yeah.
So
It's VGA more or less.
VGA is the first.
Yeah.
Just maybe a benchmark. And when customer to use it, they will give you advice. You maybe too smaller, maybe need a low power consumption.
Yeah.
So we will to change it.
Yeah. I see.
So 0.06 is come out.
Yeah. So you have to work with the customers and
Yes. So
find the solution together.
Yes.
Yeah.
Okay.
So please show us the product that you show here in the booth
Okay.
at CIOE.
Okay. So I
What do we
can
have?
introduce some our product to you. This one is our first product. It's 0.39 inch. We used this one for vertical stacking to be full color display.
Yeah.
But this one is not for commercial production, mass production, because this one is used MicroLED backplate. Because for now, in market, it does not have a mature CMOS backplate for MicroLED. So we use the MicroLED to make it.
But I've talked to a company, Sapien Semiconductors.
Yes, sir.
Yeah. So they make backplanes, right?
Yes.
So do you think this is a company that will change maybe the availability?
Maybe.
Yeah.
I think Sapien is a very good partner. We maybe have if I have the opportunity, we'll have a good relationship with them. Yeah.
Great.
This one is our currently mass production one. It's a 0.13 mono green, mono color.
Yeah.
It's a major for mono green.
And this is the resolution here.
It's VGA.
VGA, that's
Yeah.
a very common resolution, right?
Yeah,
That's
common,
what the customers demand
Yes.
currently.
Yes.
So this is in the market. Does this mean it's already in AR glasses?
Yes.
Yeah?
Yeah. We have AR glasses already have products. You can see.
Oh,
This one is already my customer to make became AR glasses.
that's interesting. So can you tell us what kind of product this is? What's the name of the product?
My customer is secret. So
Oh, okay.
I can.
So we can only show the design, right?
Yes.
Not the name. So this is, from what we see, right, the display is in the middle, right, in the nose bridge.
Yes. It's a engine in here.
Yeah. So that is to reduce the cost of the display of the whole device, right? Yeah.
Yes.
Interesting.
Okay, I will introduce our first product. This one is 0.06. This one used pitch is 2.5 micro. So the PPI is 10,000.
So the pitch is much smaller, right?
Yes.
Than this one.
Yes.
How
So-
can it be so much smaller than the other one?
You see a very important point. This one is need a very high technical process. So it's not easy to make it.
So if you increase the resolution with the same process, then
Yes.
the yield would go down probably, right?
Yes.
Yeah. So you make it a little bit smaller and then it's feasible.
Yes.
Yeah.
So this one, because small, you can make your AR glasses very compact.
Yeah.
It's close to normal glasses.
Yeah.
Yes.
And will we see something like this in AR glasses and smart glasses in the future as well? Yeah.
Yes. Yes.
Okay. What do we have here?
This one is our not other product type. It's have a lens, LED engine. So we have two type of products.
Yeah.
One is a panel, other is a LED engine. This one is a LED engine.
So you design the whole projector then?
Actually, the lens is made by our partner.
Yeah.
We provide our panel to our partner. They will alignment the LED to us.
But it's especially for you. It's made for your panel.
Yes.
Yeah. So if a AR device, AR glasses company comes to you, they can get the panel and make their own light engine with a partner, or you can provide them with this, and then it's faster, right? The whole process.
Yes.
Yeah.
Right.
Awesome. What do we have here?
Okay. This one is for intelligent headlight, vehicle headlight. So you see the panel is bigger. The size is 0.61 inch. The pixel size will be bigger because they need two brightness, you know.
Yeah.
This is application.
Yeah.
Use this LED for vehicle headlight.
Yeah.
So this one is wafer form.
Yeah.
It's 0.61 wafer, 4-inch wafer.
Yeah.
Yes, this one is 0.39 4-inch. This one is 8-inch. So we have already completed the 8-inch process. Even our factory is a 4-inch line. If we have enough money, we will construct a 8-inch.
Yeah, and
factory.
you want to go to, it's the same as with the OLED companies, right? You want to go to
semiconductor company. Yeah,
exactly. So you want to go to larger wafer sizes to bring the cost down.
Yes, yes, you're right.
Okay. So how long does it take to put all these structures onto the wafer? It's a very complex process, right?
Actually, if we have a CMOS wafer ready and epi is ready, the process flow should be 1 month. We can tape out. Yeah.
And for the power consumption,
power consumption.
How can you reduce that?
Power consumption actually depends on the wafer and CMOS wafer and EPIs combine together the process. You know, this is a semiconductor technology and process.
Yeah.
This is our, I think, our advantage in our in-house fab.
Because you control the whole process.
Yes.
Yeah. When do you think the stacked RGB single panel will come to market?
Okay, we planned we'll launch this the end of this year. We'll deliver to customer maybe next year of Q1, Q1 we'll deliver customer to evaluation or testing.
Yes. So evaluation, that means maybe another year for mass manufacturing, or how long does it take from evaluation to, like, as you said, like a million pieces?
I think the mass production should be right up, maybe slow and slow. Yeah, to be more and more to output. Outcome. Yeah. I'm sorry.
So the first products will probably be small scale production. So like a few thousand maybe.
A few thousand. Yeah.
Yeah.
It's no problem.
And so the stacking, I imagine, so making micro LEDs is very hard, right?
Yes.
It's a very complex process. And if you then stack them, that's probably even harder, right? That's
Yes.
why nobody has something like this on the market yet.
Yes.
So what are the challenges for
Okay.
manufacturing this?
Okay, it's a very good question. First of all, I think we used the semiconductor or IC my side to fabricate micro LED. You know, micro LED even belong to semiconductor the range. But actually, if you use IC integrated circuit, my side will high level to make the micro LED will be better.
Yeah. Ooh. Actually, the storage is full. I have to free up space.
Okay.
The whole thing is full with video.
Okay.
We're here with the CEO, right?
Yes.
Of Sapien Semiconductors. Please introduce yourself briefly and the company.
Hi, this is Myung-hee Lee. I'm the CEO of the Sapien Semiconductors. And the Sapien Semiconductor is mainly focusing on micro-LED display drive IC development, ranging from the micro display to the large display application. So we do nothing but display drive IC for micro LED display.
Interesting. So, what do you have here on your slide?
So here, I like to show the latest mega trend in the micro display for AR smart glasses. So as you know, there's a two mega trend. One is higher resolution, and the other one is lower pixel size. So if you see here that, as you know, most of the current product in the market is based on like VGA resolution with 4 micron pixel pitch. So that now most of our customer asking a 2.5 micron pixel pitch with various resolution from 2x VGA to 6x VGA. Means that because of the AR application usually use 4:3 aspect ratio, so VGA resolution is kind of typical in the market. Now it's moving from to the VGA to 2x VGA or 4x VGA or 6x VGA. So that's the mega trend in this end. And also, as you know, the most of the display micro display module is based on the monochrome display, mainly because of the red color issue. So in the market, in the mass production is a monochrome display, but in the future, maybe 3 or 5 years later, the one panel can support full natural RGB panel in panel. So this is my expectation based on the lot of discussion with customers over the world.
Yeah, so this is like one panel, full color.
Yeah, one panel full color is not quite ready for mass production.
Yeah.
You will see some technical demo or technical to demonstration, but what I'm talking about, the mass production ready product in one panel RGB.
Yeah.
So far, most of the panel is based on 3 R and G and B panels.
What do you see from your customers? When do you think this will start to expand?
So this is what I see. This is my own interpretation. Like when you look at the smart glasses, there's a lot of different smart glasses in the market. So I categorize into 3 different types. One is just a simple smart AR glasses without display.
Yeah.
The second one is simply the conventional 2D display, like using the LEDs. And the third one is an ultimate, objective everyone is looking for. You see, this is the object, ultimate product we are looking for. So when we move to this end, we have to support the 3D display, also along with the higher, resolution we talked about before. So this, when we develop these two Type 3 displays, the architecture point of view is quite different from Type 2. So we see that right now you see the Type 1 and Type 3 is already in the market. And then in terms of Type 2, you see more higher and higher resolution in the coming years. But I expect that Type 3 will become more available in the market in 2027 or 2028. So after that, everyone's moved to that direction.
So, I mean, even the 2D microdisplay, they are just emerging, right?
Yes.
This is a fast-moving market.
Yes.
So now we only have a few startups like the Even Realities, right?
Right.
Very popular. Now
Right.
the Rocket glasses, also very popular.
Right.
Then you go to the full color, which is still like emerging, right? Maybe
Right.
next year the market for that will grow a little bit. I think Rocket already announced they want to go to full color.
Right.
Even Reality is working on the next generation glasses as well. So what do you think, where can we go with the resolution for this type of glass, for the second gen?
So like I said, like I showed you earlier, they start from the VGA resolution. Now next step is 2x VGA, like 800 by 600. And the following generation is 1280 by like 960, something like this. So just keep multiplying the VGA, like 2x VGA, 4x VGA, 6x VGA type of resolution.
Yeah. But here at CIOE, I don't see this increase yet. So it's still maybe 1 to 2 years away before we see this, right?
You don't see that, but we already developed those products and deliver to our customer already. So they're gonna build it. I'm sure you will see starting next year.
Well, that's great to hear. I'm sure everyone in the subreddit will love to hear that.
Yeah.
Because I already see people complaining about, this is the same resolution again, right? And I also talked about that because, of course, I mean, you always want to increase the battery life as well.
Yes,
so there's a trade-off, right?
Yeah.
So you need to be, with your application maybe also, right? You need to be very smart about, as you said, only turning the display on and only exactly the amount of pixels that you need, right? So it's also the application developer who can play a role in when this will become a mass market thing, right? If you want to play a video all the time, then the battery life will go down. But if you find applications that are useful every day and you only need a few pixels, right? Sometimes you only want to know what the time is. And right? It's simple, but yeah. So you think we will see the increase in the resolution? Love to hear that.
Yeah, so we just deliver first sample this year, and with a different resolution, higher resolution. So you'll see more and more sample next year, and hopefully we see more consumer product, adopting those higher resolution display.
So, and you think even in this decade we will already see the third gen?
Yeah, I'm very positive.
Wow.
Yeah, third gen will be, you will see like 2027 or 2028. Because the actually specs, they announced they're gonna release the next year, with a more like affordable, product.
First consumer.
Yeah,
product.
first consumer product. That's more like a type 3 type of product.
Yeah.
And then I know the many like front runners are preparing this high-end product, premium product.
It has always been the end goal, right?
Yeah.
To really augment everything and put it in a certain place, right?
Yeah.
Like when you see a translation of a voice, right? When we're talking and we don't speak the same language,
Right.
I want to see your speech bubble where you are and not somewhere here completely disconnected from you. And I mean, now the Snap spectacles, right? This generation that we see here, it still uses LCOS. But you think micro-LED can be the next solution for this?
I believe that Alco's solution is more like a transitionary. Like I said, from the power perspective and form factor perspective, micro-LED will be the mainstream. Maybe you already invested a lot of investment in the companies, and most of the big tech companies or major player heavily invest on micro-LED, not LCOS.
Yeah.
So I think LCOS is still it's already mature product. So some product will adopt the LCOS product, but like a majority of the product will be LEDOS based. Sapien is only providing the CMOS backplane.
With the backplane.
Yeah, CMOS backplane only. So my customer is either micro-LED supplier or OEMs.
So, but from what I've heard, like making the backplane is very complicated, right?
It is actually because of the pixel size. We have to integrate a memory like 10-bit or 12-bit memory bit per pixel, and then also the die size has to be minimized. At the same time, the power dissipation has to be minimized also. So those are the things require a lot of know-how in terms of how you lay out, and also you have to support many IP like image processing IP or Dimura compensation and so on and on. So depending on the customer's requirement, we do provide all the custom design based on those requirements.
Yeah. So you designed the backplane, right? If I understand it correctly, but manufacturing, that's a whole nother story, right?
So we are the fabless company, so we only design the chip.
Yeah.
But we manufacture through the silicon foundry, such as Global Foundry and ST Micro or TSMC or all the global CMOS foundries. Because this CMOS backplane is based on a 22 nanometer process or 28 nanometer process. This is what we are using right now.
Yeah. And so there are companies in micro-LED that only make the LEDs, right?
Right.
And there are companies like yours who design the backplane.
Right.
And then there are companies that are the foundries, right?
Right.
So it's an ecosystem that works together.
Right.
And this is across multiple countries as well, right?
Exactly. Exactly.
Yeah. So there's a cooperation, but most of it is based in Asia, right?
Right.
So
but actually,
displays.
I would say the display drive ICs is in Asian countries very strong because they have very historically they developed like LCD drive IC or OLED drive IC and so on and on. So most of the drive IC or display makers are located China, Korea, and Japan, and Taiwan. So that's the reason why most of the drive IC supplier is also located in Asian country.
Yeah.
So now is when we move to the micro LED, micro-LED is more diverse in terms of the micro-LED supplier, like the Europe, US, Japan, and China, and Korea, and so all over the place.
Yes.
But somehow the CMOS backplane supplier is still very early stage. So the Sapien Semiconductor is one of the leading this effort.
Interesting. So, and you're based in South Korea, right?
Yes, exactly.
So that's also where some of the big display companies are located, right?
That's right. That's
so
right.
the Samsungs and the LGs.
Yes.
So how is like the CIOE? How is what role does it play in the ecosystem and building the ecosystem?
Actually, that's a very good question. If you look at the existing LCD or OLED panel, as you mentioned that the Samsung display or LG display is a leader, but when you look at the micro-LED display, they are not the active player. Actually, as I mentioned, the micro-LED manufacturer or supplier mainly located in China or Europe or US. So there's not many players in Korea. So that's why the Sapien Semiconductors customer are located in all over the place in the world. So like I said, it's China. We have customer in China, Europe, and Japan and US.
Interesting.
So I would say, when we move to the micro LED display, this become semiconductor business. Before LCD or OLED displays, display panel maker business. Now it's more like a semiconductor business because CMOS backplane is a semiconductor, micro LED is also semiconductor. So this whole ecosystem is changing from the display panel maker to semiconductor business.
And so the backplane, right? Now in AR glasses, usually you already said the trend is monochrome panel, right? This is probably growing, so you need a backplane for this. And actually in the RGB glasses, like the Ranio X3 Pro, do you have like 6 backplanes in there for every monochrome display, right? So how does the backplane architecture and design change if you go to RGB in a single panel?
So basically, you have to support all RGB, graphic data processing the one single panel instead of a separate RGB panel. So the amount of the data processing is 3 times, bigger, and also timing-wise is 3 times as bigger, so faster. So it is much complicated design. I mean, just CMOS backplane point of view, we already designed the RGB panel, CMOS backplane, but unfortunately, there's not many micro-LED supplier who can support RGB on the one plane.
Yeah. Still emerging, still R&D, right?
Yeah.
And they stack the LEDs because it must not get very large, the display, right?
Right.
You still want to put it in a small glasses.
Right. Because also the number of pixel is grow 3 times more. So that if you don't have any good control over yield, then there's a lot of issue with the yield. So, but then I think is the main problem. I'm not an expert on the micro LED device itself, but I have been told that the red color is always an issue when you making the micro LED on the same die.
Yeah. Yeah. So you said something about there's a trend toward higher resolution.
Resolution, yes.
But for the micro LED, that seems to be a problem, right? Because the higher you go with the resolution, the energy consumption goes up significantly. Maybe, as you said, the yield is a problem, maybe, right? So why don't we see micro LED challenging the OLED market in the resolution?
Well, I think it's just a matter of you have to consider this FOV, field of view, and PPD, right? So typically, if you have a very good FOV, you need about 2K by 2K resolution ultimately. So I hope that industry can make such a high resolution display without any issue. However, you have to consider when you look at the AR display market, you're not supposed to turn every pixel on at the same time. Most of the cases, display is very limited area. So that because of that, micro LED is much better in terms of the power dissipation point of view compared to other OLED or LCOS competitor.
Yeah. Can you a little bit, for someone who has no idea how this is made, can you a little bit explain the process to making a backplane? Because you have like these wafers, and on top of these silicon wafers, right?
Yeah.
You build a backplane.
So
very
this
complicated.
is what I actually have like this. So we have a CMOS backplane. That's why it's just underneath. That's why we call the backplane. And then usually we call the wafer-to-wafer bonding between backplane and the front plate. Micro LED front plate is using the wafer-to-wafer bonding. This is very typical. The process technology already used for the CIS image sensor. So once you make a bonding and cut it like this, and then you put like this one, you may have seen this kind of module already. So they make a module like this and then combine together with the prism to make a full color.
Because that's not really intuitive, right? You have like a wafer where you build the backplane on top, and then you have a different wafer where they grow the LEDs on top.
Right.
Then you somehow flip it around, and then you bond this together.
Right.
It's a very complicated, high precision operation, right?
Right. It is a very high precision process, but semiconductor process point of view, this is a very typical process.
For someone who's in the industry, that is like, well, that's how it's made, right?
Yeah.
But as a consumer, you only see the end product.
Right.
That's
Like
a whole different story.
Yeah, like I said, the CIS CMOS image sensor we have in this camera, right? This like a smartphone camera. They already use this wafer-to-wafer bonding with the sensor, image sensor, and then the driver ICs. They already use the technology.
Yeah. So the big display companies, what do you think is their role? When will they enter the market? So the Samsung, LG, but also BOE, TCL.
I think it's an AR display perspective. I think there's the big display company not necessarily have advantage over the newcomers, because the AR display is quite different from existing LCD or OLED display. Like I said, LCD or OLED display, usually they making this display based on the glass panel. But micro LED has to, should be manufactured in the semiconductor process equipment. So it's a quite different process, flow. So there's a different set of expertise and their requirement. Of course, they have a good understanding about the LCD and OLED display. However, it's not necessarily the advantage to, when you talk about the AR micro display. I mean the LEDOS display. This is one I have this snapshot of market what's available. Maybe based on your information, and I kind of see that the average price of the eyeglass pair of glasses. So $300, $500, and $1,000.
The full color 3 panels, you think like the price is going down maybe like for enterprise, right? It could be a thing with the Radio X3 Pro.
Yeah.
So in the coming years that should be adopted.
Yeah, this is kind of an indication where the industry is, where the price they're gonna try to set. I think it is over time, the yield will go up and the number of manufacturing will go up. So price either go down, but they're gonna increase the performance. So price will, over time, price will stay same, but the performance will go up definitely. Resolution go up, power will go down. So in terms of performance point of view, will increase, but price will be the same.
Well, I'm glad I came to your booth because this is really helpful. So, all right. Well, let's wrap it up, right?
Yeah,
Thanks for the interview. It's been really great. Learned a lot again. So every time here, I learned a lot, and it's really cool.
Thank you.
Thank you so much.
Thank you. Thank you.